Alright, and welcome everyone of us again to another episode of Maths Phobia. Okay, so today we're looking at another aspect of maths that students and most students run away from and they find challenging, and that is trigonometry. So this is just one of the basics. As time goes on, we'll do a class for now to solve bearing questions on bearing and distances, other aspects and administrative applications of trigonometry in a simplified form. Alright, so let's quickly look at our question. If sine x degree equal to a over b, what is sine 90 minus x degree? Alright, so we know that from what we have, sine x degree, we're given that it is a over b. And you know from SOHCAHTOA, we know that sine is opposite over the hypotenuse. Opposite over hypotenuse. So what do we have from here? Now, we have a right angle triangle. Okay? And these are x degree. Okay? Then opposite is A and hypotenuse is B. So let's call the adjacent. This base, what is it called? Let's call it the adjacent. Or the base adjacent. Okay, so this is hypotenuse. And this is our opposite side. Okay. Now, we are told that sine x is a over b. Let's find sine 90 minus x. Now, there is a relationship, all right, that exists. Okay, because the difference between sine x and sine 90 minus x is that this is just x degree, but this is 90 minus x degree. So what do we do? Okay, there's a relationship that says that the sine of any angle, let's say x, is given as is the same as the cosine of 90 minus that angle. And likewise, the cosine of any angle is equal to the sine of 90 minus that angle. Am I communicating? So what this means is that if I write sine 30 for instance, look at sine 30, I already have it here. If I write sine 30 for instance, sine 30 is the same as cosine of 90 minus 30, which is what, 60 degrees. So to find the sine of any angle, find the cosine of that angle, but the angle you are going to use will be 90 minus 30. So sine 30 and cos 60, they are the same. So sine 30 degrees is 0.5, cos 90 minus 30, not cos 30, not the cos of the angle, the cosine of 90 minus the angle. So 90 minus 30 is 60 degrees. So sine 30 degrees is 0.5, cos 60 degrees 0.5. So what if I have sine 25 degrees? What will be the answer? It will be cosine cos 90 minus 25 degrees. And that will be 65 degrees, because 90 minus 25 equals to 65 degrees. So we're going to apply the same approaches to get sine 90 minus x. So it means that sine 90 minus x is the same thing as looking for what? Cos x. So let's find cos x degree. And we know that cosine from SOHCAHTOA, cosine is what? Adjacent divide hypotenuse. Now our adjacent is C and our hypotenuse is B. But if you check, none of our options is expressed in terms of C. They are all expressed in terms of A and B. So what do we have? From Pythagoras theorem, we have from Pythagoras, okay, let's have it here. Okay, we have that the square of the hypotenuse is equal to the sum of the square of the opposite side and the adjacent side. So what does this imply? B squared equals to A squared plus C squared. Let's make C the subject formula and substitute into this place. So we have B squared equals to A squared plus what? C squared. This is positive. If I take A squared to the other side, I'm going to be having B squared minus A squared is equals to C squared. Now I want to find C, because I need C, not C squared. So I take the square root of both sides. So square will cancel out the square root. I have C to be equal to this square root of B squared minus A squared. Okay, so if I replace this into our what we are looking for, cos x degree. C is what? B squared minus a squared, everything over b squared. This is our answer. And that leaves us with option A as the correct answer. Thank you very much. Our subsequent classes, we look at how to apply the sine rule, the cosine rule, and also look at bearing and distance. One topic in mathematics that gives students a whole lot of challenge. Thank you very much. Please like and share this video to many students who are having challenges with solving questions like this, because to be of great help to them. Thank you very much. See you in the next video.